All right, welcome to Earth Science. Let's do some more. All right, I have an index card here that is torn into four pieces. I have a question for you that's going to sound insultingly obvious. What do you think happened first? This card was torn into pieces, or this card was manufactured? It had to be manufactured first, right? I can't rip something that doesn't yet exist. That rule is what we're doing here. Cross-cutting relationships. We'll write it in a sec. It's also what you would have had to have used when you did these guys up here. The snowshoes cut across the snowmobile path right here. They could not cut across it if it wasn't there, right? And that, again, that sounds like something almost insultingly silly to say, but that's the deal. If something cuts across another thing, it had to already be there. Therefore, the thing that does the cutting must be younger. What about cracks in rock? All right. If a rock cracks and faults, or in this case, these are called joint sets where there was no offset, it's just cracked. But either way, if you see a crack in a rock, let's just call it a fault. What had happened first? Did the rock form or did it break? Well, the rock had to form. It had to be there. So faults cut across rock that already exists. So this is really like the most powerful tool. Superposition's a good one, but this one's great. It's called the law of cross-cutting relationships. And again, if if you figured out this animal track thing at all, which a lot of people do, they figure it out. It's pretty intuitive. You use the law of cross-cutting relationships to do it. Now we're just slapping a name on it. If a feature cuts across another feature or layer, it must be younger than the thing it cuts across. Like that sounds wordy, but don't let it freak you out. It's a very intuitive rule. So when we get to doing these things, we're going to say that, and they put these in alphabetical order to make life easy. We'd say A, B, C, D, E, F, then a fault. Because you can't, F is broken. Could you cut F? Could you break F if it wasn't there? Um, Same over here. What this would be, this is a sign of an igneous intrusion. Let's go back to igneous rocks. Remember what they were. Formed from lava or magma. So there's occasions that where tectonically within the crust, magma comes from deep within the earth and melts its way up towards the surface and like it looks like a pipeline, right? Well, it cuts across these other layers. Therefore, those other layers must have been there. Now, I'm going to blow this way up. I'd like you to do the same. Let's look at this one close. I'm going to bring back something that's it's been quite a stretch since we've talked about this. We did it with the metamorphic rocks, so that was like part of Unit 3. We said, and I said this then, I said, we're going to do something in the future where you're going to have to draw these little things. We said that we're going to draw these little, that's way too big. Let me start that over. We're going to draw these little squiggle marks. Like this. You remember doing this back with metamorphic rocks? What it represents is a thing called contact metamorphism, which meant that the heat of this igneous intrusion that came through managed to alter these other rock layers a little bit. Not melt, because if it melted, it'd be part of the igneous intrusion, but metamorphose, change with heat on a pretty small scale, on a local scale. All right. It's a enormously important thing that we're going to have to get down. In fact, we're going to have to draw some on these because these diagrams don't have it. Other ones I give you will. It's an enormously important thing to notice for cross-cutting relationships because, again, these rocks got metamorphosed, which means they had to exist. You can't change something that doesn't yet exist. Or break. When I say break, I mean that'd be like with the faults, right? You can't change or break something that doesn't yet exist. So cross-cutting relationships is a really powerful tool for letting us know what a young thing is. And it'll get challenging in spots like, I don't know if I have any on this one. Let's zoom back out a little bit. Yeah, like here, I see a fault that broke some rock layers but didn't break K. So these other rock layers must have existed, but K doesn't yet exist. So yeah, that's going to be kind of the thing you watch out for. That's how cross-cutting relationships will be helpful. All right. Don't get too panicked about the names. It's going to be more about figuring out how to use them. I very, very rarely see the names pop up on a Regents, and I don't think many of us are taking the Regents anyway. We don't have to worry about it as much this year. So don't worry about the names as much. It's going to be more like using all these rules. And we'll practice a bunch. Everybody's going to do great. Thanks for sticking in there. I think, what, one rule to go? All right. Good luck.